Lecture number 4 for Western Civ 2, the revolution of physical sciences that takes place particularly beginning in the 16th century, and certainly makes a great difference in Western civilization's development. As we begin today, we need to reflect upon the origins of this scientific revolution. We've seen that exploration of the physical world had made dramatic changes as new crops, new foodstuffs came to be available, new markets were opened. Western society was dramatically changed by exploration of the physical world and looking at geography. But as people would explore things even where they're at and look beyond where they're at, there'll be changes that happen, and we're going to see is there'll be particularly important changes where people are going to grow in their confidence that they can understand the world in which they live, and by reasoning through the things that they observe, that they can gain advantages and do better in their life in this world. So as we begin to think about this scientific revolution, particularly the area of physical sciences, what we see is that it has its origins with Christianity. If it hadn't been for Christianity, we wouldn't have this revolution. And what we'll see along the way is that time and time again, many of these very influential people in bringing about the development of physical sciences are sons of clergymen and people who have the advantage of church schools, who begin with the premise that the world we live in is real. This is something that Christians and earlier Jews had brought to the table. God created the heavens and the earth. There's something that are real that God has brought about, and there's something that are good. Now, the world we live in is a fallen world, and as a result, things aren't the way that God created them to be. And so, as Christians, we're looking forward to the world being recreated. And even now, as God's Spirit works through us, we're following along with Jesus and undoing the devil's dirty work. And ultimately, God will create a new heavens and a new earth. But the world as we live in it is real. We live in a cosmos where there's order, not chaos. And in that order, which comes from the fact it's made from a God who is orderly, we have a real world. And if we observe creation as God's handiwork, this can actually become worship on our part. Certainly we find in Romans chapter 1 is that there is natural revelation. Around us all the time there's revelation. If we go to Psalm 19, we find that it reflects there upon the fact that whether it's day or night, that the earth, the world around us, the cosmos, is speaking of God's handiwork. His fingerprints are all over creation and all the complexity that we see and the integration of things. And so this is a beginning point here that comes from earlier times for the development of the scientific revolution in the 16th century. They believe that the world is real, they believe that the world is good, and that people have the capacity to observe the world and understand something of it. Now, they also had many ideas that great thinkers from the past had engaged in observing the world, and Aristotle had certainly made his contributions. There in the Hellenistic era, many individuals who had observed the worlds and had come up with observations that advantaged people, whether it was the physicist Archimedes or people who observed the world around them and made some rather astonishing observations that helped them to calculate the size of the earth, as we think about Aristophanes. And there were people who also thought about things beyond this earth, and people who postulated the possibilities even of the fact that the earth rotated around the sun. Now, as you've been reading in the textbook by Spielvogel, perhaps, what you see there is that he seems to see Hermeticism as being something of a trail that would lead towards this development of science, as people sometimes engage in what most of us would attribute to being so much hocus pocus. Does trying to turn lead into gold, does that really promote science? Well, there may be some things that are observed along the way, but I think that this is a false trail rather than a positive trail, where people think that through magic that they're going to accomplish certain tasks. But they are nonetheless looking at the world. As we come to the period of the Renaissance, certainly there had been growing confidence in people's ability to assess the classical ideas that had come to them and to think about them. But as we came to that religious reformation in the 15th century, there's a growing confidence of people that we can challenge ideas and traditions that come from the past, and sometimes we're going to find out some truths that may have always been there, that have been obscured because of all these traditions that have accumulated and obscured the truth from us. So as we begin to think about the scientific the revolution in the physical area, we want to look first to the classical example of astronomy. Coming from the times past, from the Roman era, you had Claudius Ptolemy, and he had advocated geocentrism, that is, that the Earth is the middle of everything. Sometimes people look at people as being rather egocentrical, think that, everything rotates around us. Maybe some people seem to live that way, that they think that everything orbits around them. But in Ptolemy's understanding of things, as he tried to understand the movements of celestial bodies, he understood the world and to lie within a system of crystalline spheres. And so the Earth is basically fixed in a crystalline sphere that rotates within other spheres. It's kind of like those nesting dolls that you have with the that are famous from Russian culture. Except here you have essentially glass spheres in which these solid bodies are embedded, and you have spheres within spheres. Sometimes you'll see something of this even in some old hymns that get sung where it talks about the music of the spheres. The idea is that everything in heavenly realms is round, it's perfect, and they're operating, and we can observe things operating just like we're looking through glass. But as they looked at the heavens, as things move, they found there were some things that didn't move in regular patterns. How do you explain planets, for example? The Greek word for planet that we use basically means a wanderer. They're not moving in the same kind of pattern that we see as we look up the stars. Otherwise, we see these constellations, and Orion's belt, from our perspective, every evening we go, it seems like it's in the same configuration. Now, it may move, again, every hour. The constellations move about 15 degrees. As we look up at the North Star, they seem to be orbiting, turning around that fixed point. But the Big Dipper, it never collapses. It's these constellations of stars that we look in the sky, they seem to be fixed. And their understanding was that those were fixed within these crystal spheres, and we're looking through one sphere to see the next sphere. And these things that are the fixed stars, they're turning around us, pivoting around us. As we come to the 15th century, people are trying to understand this. Some people are studying ancient texts, but a Polish clergyman by the name of Nicholas Copernicus had studied in Italy, the best universities of the time, and he decided to pursue the idea that rather than the Earth being in the middle and everything rotating around the Earth, that instead everything rotated about the Sun. The Earth, in fact, rotates around the Sun. He came up with his idea fairly early on in his academic life, but he didn't publish his document. Again, he's going to publish it in Latin so the scholarly world can understand it, but he writes a book entitled On the Revolution of Heavenly Spheres in 1543, and it's going to be published posthumously after he dies. He knows it's going to shake some people up, but Copernicus' observations fit within this system that he's come up with, where he explains the movements of the stars on the basis of the fact that the Earth is moving rather than the stars are moving. This is a revolutionary idea for the time, and it's going to challenge the received knowledge that came from those time-honored people that came from the Roman past. This is different from what they were holding to. It shook up some of Aristotle's ideas. His work, interestingly, is published by Wittenberg University's press right in the later years of Martin Luther. So they're going to publish this, and it'll be something that they discuss in the university, even as they're discussing the theological ideas of Luther that have been so shaking to European society. This is going to be something that shakes people up. Now, most people's lives aren't changed day by this, but others are going to come along and join in this study. Somebody who's born about the time of the publication of Copernicus' writing is a fellow by the name of Tycho Brahe. He comes from the area we know today as Denmark, and he's going to move around a little bit along the way, but he's going to be a scholar who is going to be in the employment of the local monarch. Then later on in his life, he'll move to become a scholar under Rudolf II of the Holy Roman Emperor in the city of Prague. But along the way, he's going to be given opportunity to observe the heavens. Now, he's going to be the last great astronomer who doesn't have the telescope as part of his arsenal, his equipment, to observe the heavens. But using devices that that didn't provide magnification, he can nonetheless still use things like the astrolabe to measure the stars. And he creates his celestial observatory. He's actually going to have a couple of these observatories as he has different patrons along the way. But he's going to carefully plot where the stars and the planets are. So long nights, trying to be systematic and keep records. This is going to be basic to the studies that follow. You have to have certain data. And he's going to create this research institute. And for Brahe, he doesn't buy completely into Copernicus' system. The Tychoian system was one where he believed that the planets orbited around the sun, so he's agreeing with Copernicus on that. But what he believed was that the moon and the sun orbited around the Earth. So he doesn't have the Earth orbiting around the sun with the other planets. Instead, those things are orbiting around the Earth. But he's nonetheless collecting data, and he's going to do this for years as a scholar who is helped along the way. He's a very interesting person who, again, comes from affluent families. Again, most of these people who are scholars have time to study, and he's going to be raised by an uncle, and what we're going to find is that he's been very interested in his scholarship along the way. Just as an interesting sidelight here, I'd share with you that along the way he had a duel because he and a cousin couldn't agree on resolving a mathematical dispute. And as a result, they had a duel in which Tycho Brahe lost his nose. So he got his nose cut off, and he had a brass nose that he was fitted with that prosthesis all the way through the rest of his years. But he is going to be very important in collecting data and using observatories that are going to be used to study astronomy. So, an assistant to Tycho Brahe was Johannes Kepler. Kepler lives from 1571 until 1630. And in Prague, he had served as something of an assistant to Brahe in the imperial court. He's going to continue to make observations in the observatory, and he's going to have the assistance as he goes along, in that he's going to learn from Galileo about the telescope. So he's going to get some aid of magnification in looking at the stars. Like others, he's going to be very much a Christian who believes that God created a reasonable world that we can understand. And he's going to particularly be a fellow who contributes to the use of math in proving certain scientific developments. And he's something of a prodigy as a child. But as a child, he had seen a comet very early on in his life, and then he'd witnessed a very famous lunar eclipse in 1580, and these things got him to thinking, and this is what led him into the area of astronomy. Kepler is famous for 3 laws of planetary motion. Basically, these 3 laws, to make them very simple here, what he observes is that as he goes along with Copernicus in thinking that we have a heliocentric system, is that the planets, part of the reason why that they're less than predictable here is because they have elliptical orbits. That is, they're not perfect spheres. Now, many of them are fairly close to being circular in shape, but they're elongated, and so they appear at times to move faster and slower. And so this will lead then to his second observation, is that planets do change in speed as they are closer to the moon, as they are closer to the sun. And so as they move, their speed accelerates and decelerates along the way. His third observation here on planetary motion was that the speed of planets is related to the size of the orbit in which they rotate. And so not all planets orbit at the same speed. For us, we have 365 and a quarter days roughly that it takes for us to make a trip around the sun. There are other planets whose years are much, much longer in comparison to Earth years. There's others that are faster. So he's not assuming that there's just always that things are not changing beyond the Earth. And so he's going to come up with these observations, which will be explained here in a few years by Isaac Newton, as he's going to come to explain why these planets are changing speed and why their orbits vary the way that they do. Helping Johannes Kepler would be Galileo Galilei over in Italy. He's famous as he does a number of studies in physics. Again, a lot of his things are very practical, applied wisdom. Some of his experiments from the Leaning Tower of Pisa are famous. As he thinks about using gunpowder weapons to calculate the trajectories of cannonballs, these are the sorts of things that might be very practical mathematics that he can calculate and be thinking about physics. But in his studies, amongst other things, this pious Italian man is going to turn his gaze to the heavens, and he's going to take advantage of ground lenses. Now, they've been using lenses for a long time for magnification, but something that's come up out of the Netherlands, as they are improving their capacity to polish glass lenses, is that when you have different shaped lenses and you use them in pairs, you can get even greater magnification. And so he's going to use the telescope, not just to look on land to see, hey, is there a ship there coming, matey? But he's going to instead look towards the heavens and to be able to look at things like the moon and beyond to planets like Saturn, where he's going to observe that there are rings around Saturn. And eventually, hey, there's moons that are orbiting around some of these distant planets. What he observes is that in the heavens there's a great deal of motion. And this planetary motion is something he wants to understand. And he's particularly going to be a person who embraces the ideas of Nicholas Copernicus. And so in 1610 he writes a book entitled The Starry Messenger. Now, because some of these ideas are upsetting some people, and their ideas about the centrality of people in God's creation, he'll write his second book entitled Dialogue on the Two Chief World Systems, where he have two individuals who are talking to each other. And so he's not coming out and taking a particular position, but they're basically talking about the Ptolemaic geocentric view of the universe and the Copernican heliocentric system. And so they're just having a discussion and discussing the pros and cons and how well they explain things. Now, at this point in time, what you need to understand is that in response to the Protestant Reformation, those calls for reform, you've had the Council of Trent, and coming out of the Council of Trent, one of the things that's come in that Counter-Reformation is the Index of Forbidden Books. Galileo Galilei, while he has powerful, influential sponsors and patrons, finds himself at odds with the Church. Because he's saying that the earth moves, whereas literally in the scriptures you have the long day of Joshua, where the sun, for example, is described as having stood still. What we would observe today is that this is phenomenological language. Even today, with all our sophistication, we don't say, oh, this morning the earth rotated. We say, oh, the sun rose. From our perspective on the surface of the earth, the sun rose. Is that we are somehow intellectually backward or ignorant? No, we describe things from our point of view. And so there's not a problem here with this, but for some people in this time period, Galileo's ideas were certainly disturbing. For them, it suggests the idea that somehow people weren't the center of God's attention. If they're not in the center of the universe and everything rotates about the earth, well then perhaps God's focus isn't upon us. And so they're going to have problems with this. Now, God's knowledge of things isn't dependent upon them being in the center of his vision. Maybe in photography you have this principle of thirds, and where you want to get your chief objective in the middle of your photograph. But God's ability to pay attention to things doesn't require that things be physically in the center of things. But certainly what we'd observe is that people are precious to God, being made in his image. And we have been the subject of God's special attention as special creatures made in his image along the way. Being geographically here not in the center of the solar system doesn't take away from mankind's special position. Well, Galileo is going to be seen as something of a champion of science, as some people who are particularly hostile to Christianity like to highlight that he's a martyr for science. Now, he never dies, contrary to what they say. He never dies for science. He does suffer his books being destroyed or being withheld from publication, being there on the index of forbidden books. He does suffer being under house arrest. He is brought before legal courts where he's going to save his life. Unlike Luther, who says that unless he's convinced by the scriptures and reason, he can't recant, and so he stands up before Charles V, the Holy Roman Emperor. Galileo is going to recant to save his life so that he's not tortured and killed. But allegedly, as they take his works and they condemn his works, he mutters under his breath, "But it still moves." All the observational information he has points to the fact that the Earth is moving, and that other things are moving around it in terms of the moon, but that the Earth is moving around the sun, and these other planets are moving there in the heavens. So Galileo opens the door to many other people who are going to be using the telescope to observe the heavens, to learn more about the planets, and they're going to be collecting data. Particularly Johannes Kepler is collecting data which will come to be understood when the English scholar Isaac Newton, he lives from 1642 until 1727, when he applies his mind to this. Now, Isaac Newton's another interesting character who again comes from a situation where he has some opportunities. He's not as wealthy going into this as some of these others, and doesn't have some of the same privileges, but he's going to be able to study. He kind of does work study as he goes to the university there in England. But in the year 1665, this is just right before 1666, when there's a great fire in London. But in 1665, the university is closed there at Cambridge because the plague has come to town. In his year off, when school's closed, he applies his mind to things, and he invents calculus. This is going to be something that he invents, and there'll be a long dispute in the years that follow over who invented this first. At the same time, over in Europe, you have Gottfried Leibniz, who also invents calculus. This is going to be important in the analysis using the numbers that are being collected here by these astronomers. Eventually, fairly early on in his life as a scholar, in 1687, he produces Principia Mathematica. Again, everything in these days amongst scholars is being printed in Latin. That way scholars in the continent who don't speak English can understand this. So if they're French, if they're English, if they're Italian, all the scholarly world is speaking Latin still. The Principia Mathematica would be translated for us as the mathematical principles of natural philosophy. In this work, he's going to explain why things are moving. He's going to be particularly a scholar in the area of dynamics, why things move the way they do. Now, in my lifetime, there's some ingenious folks who came up with the pet rock. And the great, brilliant marketing stuff. I can still remember people going and buying pet rocks, where you have a nice, smooth river rock, and the most value is just in the packaging and in the instruction booklet that comes with it. If you can get an instruction booklet, then you don't really need to buy the pet rock, and you can learn everything you need to do to train your pet rock. For example, you could tell your pet rock, stay, and pet rocks are particularly good at doing this, and they'll be undying in their devotion to be obedient to you, and they'll stay put. Well, we know that rocks don't have legs and they don't move unless someone or something moves them. But where do we get all that from? Well, in these three laws of motion that come out of Newtonian physics, what he's going to assert is that an object stays at rest, or if it's in motion, it continues in uniform motion in the same direction and same speed, unless something acts upon it. So if I would put my coffee cup on a table, it's going to stay there unless somebody unbalances the table, or unless someone who's sufficiently strong picks it up and moves it. So an object's going to stay at rest, or if it's in motion, it's going to continue in motion unless there's some other force that acts upon it. When an object is moving, or it is even stationary, change in its position or in its movement is going to be proportional to the force that's applied to it. So my coffee cup will move if I just tap it. If I hit it hard, it'll fall off onto the floor. If I hit it hard enough, it'll fly across the room and hit the wall. It depends upon how much force I apply to the coffee cup. So the third law here, which we've already seen at work here, is that for every action, there's an equal and opposite reaction. So as I strike the coffee cup with the back of my hand, there's a reaction. Now, while I hit it, there's also a reaction in the back of my hand. My hand's probably stinging if I've hit it hard enough to fly across the room and to hit the wall. I've absorbed energy here in the back of my hand where there's not a whole lot of padding, and the back of my fingers may well be bruised as a result. So while there's energy applied to this cup, which is in a position where there's some inertia there, as I add energy to it, it flies across the room, but at the same time there's an impact on my hand that I'm going to be probably wincing over and rubbing my fingers. As he puts all this together, what explains all of this? What he's going to come up with is the universal law of gravitation. What explains why things move? As he goes and applies this to things like Kepler's observations about planets. He can take his mathematics, and mathematically we can calculate where things are going to be based upon these mathematics. We can understand why things are where they are. We can calculate a number of things. And with the law of gravitation, there's some very interesting practical applications, particularly in the area of tides. How do you understand the tides? Why does the water seem to come up and go down during the day? What causes that to happen? Well, what he understands is that we have the gravitational pull of the moon that causes the Earth's surface and the surface of water to bulge because of the mass attraction that goes on there. And this explains the coming and going of the tides. Why, when you have full moons, you have these super high tides? Well, it all has to do with the position of the moon, and also when the moon is closer to the Earth, there are higher tides that take place. There's greater force that's applied. As a result, he comes to create an idea that gets to be widespread, that people can figure out the world in which we live, and if we understand that, we can calculate things, and if we can figure things out, we can get along better in the world. The world is seen to be something of a great cosmic machine, like these clocks that have been developing since the Middle Ages, where there are cogs and wheels that release certain energy as springs unwind and turn these gears. The world is this great machine which we can now understand why things are operating the way they do. Now, Newton is a very religious man. I wouldn't say necessarily that he's so terribly pious. He is going to try to study the Bible along the way and come up with a chronology and calculate the age of the earth. He's going to be very much egotistical, thinking that he's something of a specialist in all manner of fields. Perhaps he would have done well to stay out of biblical interpretation. He's going to go off on a lot of wrong-headed notions along the way, but he's seen to be a great genius who's going to come to be, for about 2 decades, the head of the British Royal Society for the Promotion of Natural Knowledge, and he's going to have great influence in English society. But his theological speculations have not been that terribly influential. Now, during his life, he will stay within the church, but he never takes religious orders as he teaches in universities, which was common in those days. He never marries, but he stays within kind of the shadow of the official church. But it's clear that he has problems, particularly with the doctrine of the Trinity. How God the Father is God, God the Son is God, and God the Spirit is God, all at the same time, and yet they're one. You have 3 persons and one God, and how that's possible. He has his real problems. He writes actually to I think it's John Locke, about 1 John chapter 5, verse 17. I think it's 7 or 17, where it talks about the Trinity there. Perhaps this explains why he never takes on orders, but he does think that he's something of a Bible scholar and a specialist in a number of other areas as well. He is going to set the stage, however, for continued confidence that people can understand the world, and he's going to get people to chase after laws in creation. Again, some of his wrong-headed notions when it comes to Bible interpretation, numerology, he's fascinated with numbers, but trying to use numerology to explain the Bible and there's a lot of wrong-headed stuff that he goes into, and it seems that perhaps his health was affected. Maybe that might have also affected something of his personality, as he was probably doing a lot of experimentation with mercury along the way. A number of these early scientists do themselves damage by some of their experiments. Isaac Newton is going to create a great deal of confidence in people's ability to understand and explain the physical world. There's going to be a quest for laws in all kinds of areas of knowledge, areas of science. So as we think about the development of physical sciences, we want to move from the area of astronomy into the area of physical sciences that you might have studied along the way, like chemistry, biology, and the like. In the area of chemistry, following on the heels here of Isaac Newton, a very important scholar will be Robert Boyle. Robert Boyle is going to be another Christian who comes to this. He's very much a committed Christian who is going to make something of a wealthy life, and he's going to champion Bible translation in the vernacular for various groups of people. Again, he's living in England, and he's going to write something of a very important book along the way entitled The Skeptical Chemist. What we're going to find is that he's very much influenced by Francis Bacon, who we'll talk about a little bit later. But perhaps some of you along the way have heard of Boyle's laws. These have to do with gases and pressure. Now, when we have the coming of a weather system here in North Carolina, we're interested in what's the atmospheric pressure I mean, it's not something we see, but there's a whole lot of winds that happen around here. Windiest place I've ever lived, because we're right here on the coastline. And particularly when there are hurricanes that are coming across the Atlantic, we're concerned about what's the pressure, because the pressure differential will lead to higher winds. The greater the pressure difference, the higher the winds. And so we're interested in high and low pressure systems that are come our way, because it's going to affect our weather, and it may even be something rather calamitous if the winds are moving fast enough. He's going to study gases and pressures, and as he studies air pressure, he's going to make a number of observations and generate Boyle's laws. If you have just thinking about air pressure, we talk about inches of mercury. What in the world's going on with that? Well, what you have is a glass rod that has a hole up through it. It's basically a tube, and it's in a pool of mercury, and as the pressure increases, then the mercury goes up up that graduated tube, and you can discern what the air pressure is. And so what he's observing is there's fluctuations in air pressure here, and it's explained by the laws that he comes up with. So in the area of chemistry, maybe that's more along the areas of physics, but he's also studying chemistry. Again, his work is going to largely take place in the area of chemistry, but this is a very pious man who's looking to explain the world in which that God has made. Another English scholar comes a little bit later, will be Henry Cavendish. He's going to be recognized by some as being one of the fathers of chemistry, along with Antoine Lavoisier in France. Henry Cavendish is another English scholar, and he's going to, together with Lavoisier, have the idea that in chemical reactions, that things just change. As we have chemical equations, when we change something on one side of the equation, the circumstances may change. As we add heat to one side to water, it may become steam. But in that process, there's nothing created or destroyed. There's a transformation that takes place, but we haven't created anything. We've just made a change. We've produced a transformation through the application of heat. If we take the heat out, then the water will condense. And so these three individuals, Boyle, Cavendish, and Lavoisier in France, are going to be the fathers of chemistry. Lavoisier, again, jumping a long time ahead up until he dies in 1794. He dies in the French Revolution as an enemy of the revolution and revolution people. Lavoisier is going to come up with the idea of elements. When Cavendish is doing his experiments, they can talk about atoms, but they don't really understand that atoms are different. It's not just different configurations of some unbreakable little unit, but that there are different size atoms. So for Henry Cavendish, he basically, when he discovers hydrogen, it's just flammable air. But people like Lavoisier are going to be able then to discern that this is a different element. So they're studying the physical world. They're trying to understand this, and they're going to grow in their understanding of these different elements and the properties of these elements. For you and I, they appear on a periodic chart that perhaps we studied along the way with those gases, those small atoms that are at the head of the table that don't have the great atomic weight as these heavy metals have at the other end. As we continue with this discussion on the development of physical sciences, and particularly looking at the areas that come under that, we want to move from chemistry to talk about biology. Looking at plants and animals is something that's certainly of interest and a practical application that helps people to get along better in the world. When we understand these things around us, we can sometimes help plants to do better and be more productive and provide fruits or vegetables or the kind of things we're looking to get from it. And certainly people in times past have been interested in cultivating plants and animals, as we see coming out of the Middle Ages. This was something that could be of great advantage. And yet in the study of biology of plants, for example, an important tool that's going to come along is going to be using those polished lenses, when instead of looking to the heavens and far away, they look at things up close, getting down even to the cellular structure of plants. This will be the contributions that are particularly made by Robert Hooke, a English scholar of plants. Subsequently, you'll have the applications that are made by Anthony van Leeuwenhoek. But all these studies of plants and animals, they're going to be something that is brought together by a fellow by the name of von Linne, a German scholar who is going to create the Linnean classification system of taxonomy, where you organize things according to certain characteristics. Perhaps sometimes you played the game 20 questions, or you might put it in the name of the game you might have played might be Hangman, where you've got to get to discern what something is that somebody has in their mind within 20 questions. So you might begin by asking, is it animal? And they can answer in yes or no. Is it vegetable? Is it mineral? Well, you may have gone through 3 questions already. But by asking these questions, you're able to cut out so many things that exist in the world. So the study of biology is something that is interesting, particularly in the area of animal science, but also it's going to be in the area of people. And this will have applications in the area of medicine. Now, in the Renaissance time period, we had people like Da Vinci who engaged in study of cadavers, dead bodies, particularly as he was interested in understanding how the body works, and so that way he could make more accurate physical representations of bodies and how they move and how they work. Certainly those things would contribute to people's understanding of bodies and all, but until you are able to really bring something new in that microscope or that magnifying glass to the task, a whole lot of old ideas hold on for a long time. The Roman doctor Galen had seen in the body a number of humors. Now, maybe at some time you've done some dissection in a biology class where perhaps you got a package of different kinds of creatures that had been prepared for you to dissect. Maybe at some time you dissected a fetal pig, and maybe they might have helped you along the way as they've injected latex of different colors into the arterial system and the veins of a fetal pig, and they might use different color latex so that when you look through the walls of those vessels, they're different colors, and so you can discern the difference between a vein and an artery. But the Roman Dr. Galen was highly respected for years and years. But he basically is looking at different types of fluids in the body and understands people's health and well-being based upon these fluids, these humors in the body. He didn't understand, why blood might be bright red if it comes out of an artery, and why it's a darker color if it comes out of a vein. It's going to take some doing for that to come to be understood. But they continued to study the human body. Vesalius particularly studies on the fabric of the human body in 1543, but he's working at a time before you have the application of that magnification that comes with microscopes. William Harvey the royal physician to King James I of England, and then subsequently to King Charles I of England, is going to be a person who finally comes to understand the relationship between the supply side, that is when the oxygenated blood that's come out of your lungs is pumped through your heart to supply oxygen to your body, why it's bright red, and then how it returns to the heart in the veins, and that blood is dark red. Now they still don't understand all of the chemistry at this point in time. How, when you inhale those red blood cells, those corpuscles get all excited. They essentially rust when you put oxygen to them there in your lungs, and then that oxygen is taken to your body, which needs the oxygen, and then we have, where is it that you have this transition between the arteries bring that bright red oxygenated blood, and then it comes back to the heart to be reoxygenated as that dark venous blood. Well, using a microscope, he can discern that what happens is we have a transition through the capillaries, these microscopically small vessels that allow the blood to go from the supply side to the return side of the body. This is going to put aside a whole lot of mistaken notions here as they come to understand the circulation system in the body, and as they continue to study cadavers and understanding bodies, this will be an ongoing effort. But how does this make a big difference? Well, as they're studying bodies and understanding things, if we jump ahead to the 18th century, in 1796, a physician by the name of Edward Jenner will engage in vaccination. So he gets the moniker as being the father of immunology. He basically takes a young servant boy by the name of James Phipps and inoculates him with the pus that comes from certain blisters from a milkmaid, and she's suffering from cowpox, and as a result, James Phipps will be the first person who's inoculated in this manner against smallpox, which was a deadly disease. Now, what they'd observed, again, this is being scientific, the idea about inoculation that Edward Jenner came up with was actually something that had come out of the Ottoman Empire from Turkey. There they had practiced something called variolation, where they had actually deliberately infected people with the idea that then people who once had smallpox would no longer be vulnerable to that. So if you survive the practice, then you might well then be able to fight in battles and not to fall prey to smallpox. But what he's observed is that people who got cowpox, an unpleasant and sometimes scarring disease, did not get smallpox, a much more deadly disease. And so by inoculating people, giving people a light case of cowpox, then they became no longer susceptible to getting smallpox, which was much more deadly. Now, there were a whole lot of interesting ideas that people had. Some people thought that if you take this material from the cowpox, maybe you might become a cow or something. And there's some interesting stories that are told as people resisted inoculation. But this would be an indication of how through observation that through this biological science and observation, that a difference can be made in people's lives. Some people see Edward Jenner as being responsible for having saved millions of people because they're no longer suffering from these diseases that for which we can be inoculated. As I try and wrap up here, I want to come to the area of the philosophy of science. Maybe we could have talked about this a little bit earlier, but there are two major streams that develop at this point in time. One of those is going to be with Francis Bacon. He's recognized as being the father of empiricism. He's a fellow who lived during the reign of Queen Elizabeth, and he's going to have a very influential political career. But like many of these others, Francis Bacon saw himself as a person who was in the world in order to serve God, to find truth, and to serve people of his country. So he's going to be very much involved as a politician, but he's going to promote the idea that we observe the world around us, and this is going to set a direction for English science, where they're going to be much more empirical. They're looking at data, and he's going to particularly use inductive logic, where you're going to look at example after example. And in 1520, he would write his work in Latin, Novum Organum, his new instrument, and he's going to assert the importance of making observation. Now, he's going to have a great deal of influence on subsequent science here in Europe. Very interestingly here, he dies as a result of one of his science expeditions, exercises. It's not that much of an expedition, but basically what he was looking at was the effect of freezing meat. He's of the opinion that if you take snow, you could keep meat longer, and so he had a woman slaughter a chicken and gut it, and then he basically went out in a snowstorm and stuffed it full of snow and was observing what all happens as meat cools, and apparently as an older man got himself cold and wet, and subsequently he died of pneumonia here as maybe something of a martyr of science. But he certainly lived in interesting times. He lived during the reign of Queen Elizabeth I and James I into the reign of Charles I. What is important, though, is that he is going to do observational science, and he's going to inspire a whole group of people who follow in his wake in England, people like Isaac Newton, of whom we spoke earlier. In France, an important figure there in the development of the philosophy of science would be René Descartes. Descartes is a French philosopher and mathematician who is going to engage in deduction. So whereas Francis Bacon approached things through induction, looking at examples, inductive reasoning would be, this yellow apple is sweet. I eat another one. This yellow apple is sweet. This yellow apple is sweet, and I come to the conclusion the yellow apples are sweet. What Descartes is going to do, rather than going inductively, is he's going to work deductively, and he's rather an amazing mathematician who is going to become the father of analytical geometry. But as he moves through his life, his most famous two works are going to be his Discourse on Method. That is his primary work. How is it you approach learning about the future? And he's very, very skeptical. Now, he's going to be certainly within the Catholic Church in France. He needed to be, otherwise the French king would have done away with him. But he's going to be particularly connected. He's not going to be particularly active, unlike some of these others who are motivated because of their Christianity to do what they do. But in his Discourse on Method in 1637, he's attributed the famous idea, je pense, donc je suis, or in Latin it would be cogito ergo sum, I think, and so therefore I am. Again, he's operating within the Catholic Church because that's what he needed to do in France at this point in time. But he's going to engage in deductive reasoning. His argument for the existence of God is based upon his deduction. God has to exist according to his argumentation. Now in France, another important person for the philosophy of science would be Blaise Pascal. Like Descartes, he's living in France, so he's going to come from a Catholic background, but he comes from something of a dissenting Catholic background known as the Jansenists. And Blaise Pascal is an interesting person in his development of calculators. While he himself is something of a mathematics prodigy, he's going to develop calculating machines and try and help other people who aren't quite so good in mathematics to do their arithmetic. But where he's going to make some of his observations and contributions will be in the area of hydrostatics and hydraulics, understanding things like, when you might draw, let's just say to draw medicine up into a syringe. This would be the kind of thing that his scholarship would address. But he dies young and doesn't finish all of his work. His most famous work are his pensées. In French, that means his thoughts. But his working title before it got that title was The Defense of the Christian Religion, where he is very clearly a Christian who is seeking to keep scientific inquiry of the world and faith in God in one place. Something you might look up that comes from him is Pascal's wager. He wagers that it's much safer to believe that God exists than he doesn't exist. And you might look that up as a topic of interest. But all of these people up to this point in time are not breaking with the church. They're operating under its auspices. Again, sometimes these Protestants are operating in situations where they're even working under Catholic rulers. We talked there about some of those astronomers earlier. Some of those, like Kepler, were Lutherans who worked for Holy Roman emperors. They were basically able to keep their position as scholars because they had the protection of their patrons who were Catholic and had the ability to protect them. Science is going to be something that comes to be promoted for a number of reasons. So we want to look here at the promotion of science. It's promoted because of what you can get out of it. There are economic motivations. There are also political motivations. Again, what we've seen before is that economically, if you can understand certain things, you can get ahead. You can make processes work that are going to be beneficial. Politically, if you're the mathematics help you in landing your projectiles on somebody else with greater efficiency. There's military application that might be in that, so it might be something that would be beneficial. If we can learn how to develop something in this country, then we can steal from the economic pie of others. They'll come buy things from us. So there's economic, political things that get tied together. Beyond that, there's just intellectual curiosity. Curiosity is driven by some of these individuals. They have experiences. They see a lunar eclipse. They see a supernova. Hey, there didn't used to be that star, that light in the sky. Where did it come from? There's changes that are taking place out there in the heavens. Intellectual curiosity certainly helps promote science. But then there would also be institutional curiosity that gets developed, particularly in the 17th century. In England, the Royal Society for the Promotion of Natural Knowledge was something that was given a royal charter by Charles II. And he's going to be associated here with the name of Carolina. It's from Charles we get our name Carolina. But after the English Restoration of the royal family here, after the time of Cromwell, Charles is going to promote this new society, one where Isaac Newton will be for about 20 years the president. And the thought is that understanding the world is advantageous for England. And so this would be something that is worth supporting and the king would put his name to. That society will have members, fellows they call them. So if you see somebody who has the initials FRS after their name, that means that they're a fellow of the Royal Society. The motto of this society is one that in English would translate, "Take no one's word." In Latin that would be nullens in verba. Take no one's word. Don't believe anybody. Basically, you've got to prove it yourself. In the Royal Society meetings, they're going to have experimentations as they follow the ideas of Francis Bacon. They follow his approach. They're going to be empirical scientists, and they want to be able to repeat experiments. Francis Bacon is the father of the scientific method where I conduct an experiment and there's repeatability in order to prove my argumentation here. If I can't repeat an experiment, then I don't understand what's going on there. Every time, if in a carefully managed experience, the results should be the same. So in England, the Royal Society is going to be something that is promoted by the king, and which will be supported by affluent fellows who come to join it. They're going to be elected to membership in the society, and it continues to be a prestigious society today that advises Parliament in England on various scientific matters. In France, a few years later, in 1666, Louis XIII will promote the Academy of, I guess it would be in the time of Louis XIV. He's going to promote the Academy of Sciences. Sometimes this is part of the Académie Française. It's a larger group made up of smaller societies, but the Academy of Sciences, which is one of the 6 major components of the Institut Français, is a scientific group that's looking to share knowledge and to advance France through scientific knowledge of the world and how things work. These scientific things that individuals and institutions develop are going to be promoted through improved communication means. Particularly with the development of the printing press, while the Bible is being produced in different languages, there'll be other documents that are printed in vernacular, the common language of a people group, as well as in Latin. And with the printing press, new scientific ideas, new knowledge can be communicated and transported and carried. As there's increasing mobility of people, they can take ideas from one place to another, this new science. As we come to the end here of this lecture, though, we need to understand the impact of this on society. It changes society. It's going to be a major factor here. This study of physical sciences and growing knowledge there will be a major factor in directing Western European civilization towards developing the Industrial Revolution. It's going to provide a foundation for looking for laws in the areas of social sciences as well, to understanding the world in which we live. And that will be a foundation for the Enlightenment. Again, they come with the presupposition that the universe is understandable since it's governed by laws. You can discern these using the scientific method, and as a result they come out of this with greater confidence in people's ability to understand the world in which they live. Now, along the way, there's some things that develop that are not what some of its proponents would have desired. Namely, that sometimes there's a discrediting of religious authorities. When religious authorities went outside their sphere of knowledge and made assertions that are beyond the scope of their capacity. When people who are biblical scholars presume to make pronouncements on things like mathematics, and to judge these things based upon sometimes a lack of knowledge on their part. So the growing confidence in people's ability to understand the world is going to lead them to continue to explore, and this is going to change Western society in dramatic ways. I hope that as you discuss the contribution for this time period, you'll see that we continue to have a number of significant things that have come out of this time period. Some of them are going to be good. Some of them are going to be things that create obstacles in the minds of some when it comes to their faith. For others, the quest for knowledge is just something that helps them to grow in their appreciation for God as they understand the world and the universe that He's created.